This lesson we're going to be talking about graphing from standard form. By the end, you should be able to graph a line from standard form, use tables and real-world information to graph a line. Standard form, we hear this word a lot. There are standard forms for doing a lot of different things. We have a standard form for doing our taxes. We have a standard way of taking tests. We have standard models of a car. When we talk about standard means that it's the baseline. So this is the official way, or at the minimum way that you should do this, right? When we talk about a standard car, the standard car comes with things that are standard, such as the steering wheel, headlights, tires, seats. But then if you want to look at things beyond that, then we call those add-ins. Like if you want leather seats, or if you want a touchscreen radio. Those would not come standard in every single car, just like with taxes. There's a standard way of doing taxes, but there are deductions that people can take. And so the standard form of a linear equation is has the same principle. This is our baseline way of writing all linear equations. Every single linear equation can be written in standard form, but there are other ways that we can represent equations, such as point-slope form and slope-intercept form, which could give us a little bit more information. When we're talking about the ways to graph a line, remember that there are several ways that we can graph. You can graph by making a table of values. If you have a direct variation of proportion relationship, you can graph using the slope and starting at the origin. From slope-intercept form, you could graph where you start at the y-intercept and you follow the slope. And then in standard form is where we begin to graph using our x and our y-intercepts, figuring out where the graph crosses at the x-axis, where it crosses at the y, and then connecting those 2 points, because we know that we only need 2 points in order to make a line. We're talking about standard form. The standard form of every linear equation is ax plus by equals c. A, b, and c are all numbers. A and b are coefficients, and c is our constant. Remember, the coefficients are the numbers that come in front of the variable, and the constant is the number that does not change. When we talk about graphing from standard form, what we would do is we would find the x-intercept. Remember that the x-intercept has another name that it goes by, and it's called the zero. But this is where the line crosses the y-axis. And the important part for us here is that this is where the y equals to 0. So in our standard form of our equation, when we want to find the x-intercept, we would make y 0. So in this case, in 2x plus 3y equals 6, if I want to find the x-intercept, I would just simply make the y value 0, and we would solve for x. By making the y value 0, that the 3y part goes away. We're left with 2x is equal to 6. And so we know x is equal to 3. So our x-intercept would be 3, 0. To find the y-intercept, this is where the line crosses the y-axis. This would be the opposite of the x-intercept. And so instead of making the y 0, we would want to make the x 0. So we would make the x 0, which would mean that that x term would go away, would disappear, leaving us with 3y is equal to 6, or y is equal to 2. So we would end up with our y-intercept of 2. Once we have those 2 points, then I can graph those 2 points and make our line. All right, let's look at an example. So we want to find the x and the y-intercepts and find the slope. If we're finding the x and the y-intercept, anytime that we're doing that from standard form, I'm going to make a table. I'm going to have one where x is 0, one point where y is 0, and then we're going to solve. So again, if we want to find the x-intercept, remember that's when we make y 0. So that would mean that the y point would go away, and what we're left with is x is equal to 7. So that would be our x-intercept. If I want to find the y-intercept, we do the same thing, except this time we're going to make x 0, which means the x part would go away, and we would have y is equal to 7. So in this case, our slope our points, our x and y intercepts are both 7. We're finding the slope. Remember that we can find slope from a table by looking at the change in the y over the change in the x. So my y's decreased by 7 as my x's increased by 7. So we have negative 7 over positive 7, or m is equal to negative 1. If we're looking at our table here, remember that the x-intercept is when y is 0, so our x-intercept here would be negative 1, 0. Our y-intercept would be when x is 0, so our y-intercept here would be 0, 3. And our slope would be the change in the y to the changes in the x's. So as my y's decrease by 3, or increase by 3, as my y's increase by 3 each time, so from negative 6 to 3, that's plus 3. From 3 to 0, that's plus 3. From 0 to 3, plus 3. As my y's are increasing by 3s, my x's are increasing by 1s. From negative 3 to negative 2, negative 2 to negative 1, negative 1 to 0. And so we end up with the slope of 3 over 1, or m is equal to 3. For looking at our graph, remember that the x-intercept is where it crosses the x-axis, so that's at 5, 0. That's where we're crossing the y-axis, that's at 0, 5. Finding slope from a graph, again, you're looking at change in y over change in x. This is vertical change over horizontal change. So as I go from one point to the next, I count my vertical change, which is, for this case, minus 5. My horizontal change, for this case, went from 0 to positive 5, so that would be plus 5. So negative 5 over 5, which is also equal to negative 1. If we're looking here, we have our x-intercept of 0, we have our y-intercept of 5. We're graphing those 2 points. So y-intercept of 5, x-intercept of 4, and we connect those 2 points. It would be helpful if I could get my line great. Let's try that again. All right, we're going to connect those couple of points. Again, it might be helpful to use a straight edge when you're using the x and y intercept so that you make sure that you get an accurate line. When we're graphing from here, again, our goal is to find the x and the y intercepts. So for finding the x-intercept, remember that that is when we are making the y 0. We're finding the y-intercept, that's when we're making the x 0. So if I make my y 0 here, that y goes away. We have negative 5x equals negative 10, which means that x is equal to 2, positive 2. So my x-intercept is 2, 0. My y-intercept is when we make the x 0. So when I make x 0, this term goes away, and we're left with y is equal to negative 10. So my y-intercept is at negative 10. So if we're graphing this one, we would graph at 2, 0 for x-intercept. We would graph at 0, negative 10, which would be somewhere down here. And connect our points. Remember that our domain and our range is all real numbers for both, because it's it's not a real world situation. So all real numbers. And then our slope would be our change in y to our changes in our x's. So my y decreases by 10. That's negative 10. My x decreases by 2. That's negative 2. And so our change in y of negative 10 over negative 2 simplifies down to 5. And so our slope for this graph is 5. Looking here, we want to graph, or we want to change this to slope-intercept form and graph. For changing from slope-intercept form, remember that this is a literal equation. For slope-intercept form, the y is by itself, so I'm keeping the y over here and removing everything away from it. So we ask ourselves the question, is there anything being added or subtracted to the y? And there is. That would be the 3x, so we want to move that by subtracting it. 3x moves away from this side, and so our new equation becomes negative 2y. Clear that. Becomes negative 2y is equal to negative 3x minus 6. We want to put the variable part in front. And then we ask ourselves the question, is there anything being added or subtracted to the y now? That answer is no. Then we move to, is there anything being multiplied or divided? And there is. There's this negative 2. So we're going to divide everything by negative 2. And what we end up with is y is equal to, well, negative 3 over negative 2, that's positive 3 over 2x. And negative 6 over negative 2 would be positive 3. So here's our slope-intercept form equation. Y equals 3/2 x plus 3. This is helpful because then I can graph my y-intercept of 3. And then I can use my slope of 3 over 2 to move up 3 and right 2 to get new points. So up 3, right 2 puts this point here. Or I could go down 2, or down 3 and left 2. Down 3 and left 2, down 3 and left 2 to get the remainder of those points. The reason why it's convenient to graph in slope-intercept form is because it gives me more points, and then that having more points helps me to better draw our line. Before watching the next video, I would like for you to consider how we would find the x and the y-intercepts from standard form of an equation. As usual, please subscribe to the channel so that you get updates when new videos are put out.